All right, so new unit, Unit 8. Again, this sheet is going on page 47. Your scavenger hunt from the last unit should have spanned pages 45 and 46. So again, this is going on page 47. And then make sure you have the page numbers in for 48 and 49, which are going to be today's lesson, law of signs, and then the prep work for today's lesson. So the yellow page that has law of signs on it, that is going to be on page 48. And this is the goal that goes along with today's lesson. You'll be able to find sides and angles of non-right triangles. Again, this starts on page 48. Page 48. Law of signs. This is the formula for the law of signs. This is what should go in that space in between law of signs and example. Okay? This formula, A divided by sine A equals B divided by sine B equals C divided by sine C. This is the formula that you use when you are using the law of signs. And what is this talking about? Well, in a triangle, and it doesn't necessarily have to be a right triangle, okay? A, B, and C, capital A, B, and C represent the angles of the triangle. And then lowercase a, B, and C represent the side lengths across from those respective angles. Okay, so side A is across from angle A, side B is across from angle B, and side C is across from angle C. Okay, that's in relationship. Now, not every triangle is going to be labeled A, B, and C. Okay, if a triangle is labeled D, E, and F, okay, it does not change this formula. It would be side D over sine of angle D, side E over sine of angle E, and side F over sine of angle F. It doesn't make any difference what the letters are of the triangles. Everybody understand that? Yes?
Can it be numbers?
No, it will not be numbers. Okay? Now, one thing also, this particular formula, you will only use two fractions out of the three at one time. Okay? So if you know side A and angle A and side B, but you don't know angle B, then you'll just use those two in the formula. Okay? Or if you know B and angle B, and you know angle C but not side C, you will use these two. And then of course you can always use A and C. Are we understanding? Okay. So when do you use law of signs? Well, you use law of signs in these two particular situations. That's when you know two angles and one side. That's angle, angle, side. Or side, side, angle. That's when you know two sides and an angle opposite of one of the sides you know. Side, angle, side is for a different law. Yes. Yes. Mm-hmm. Yeah, so the abbreviations come from your geometry days of Euclid triangles. Okay? But you know two angles and one side. And if you look at this, the side is not in between the two angles. And in this case, which is side, side, angle. Not angle, side, side, okay? You write that on your paper, and trust and believe, I might call you one, okay? So, don't do that. Don't do that. Now, side, side, angle is called the ambiguous case. A lot of people say check for the donkey, okay? Because you know the other name for a donkey is that inappropriate word, which shall not be said in this class, okay? So, these are your two cases. These are your two cases. Okay, so this particular case, okay, a side, side, angle, it is known as the ambiguous case. And the reason why is because when you're given side lengths and angle measures, there might be a chance that you would have two triangles, okay? And this happens when the side that's across from the angle you know is less than the other side that's also given to you. This only applies in the side, side, angle case, okay? This basically means that your sign is in quadrant 2, which creates an obtuse triangle, okay? If you look at this diagram right here of the whole potential two triangles thing, there are two triangles here. And I know people are going to say, well, no, there's three. No, for this case, there's only two, okay? You have this triangle right here where this angle here is acute, but then you also have this angle or this triangle here, and you have that angle, okay? And when you have these situations where it's side-side angle, you always want to check for the second triangle, aka the ambiguous case. Question.
Why doesn't it do obtuse?
Why does it do obtuse triangles?
Like, why doesn't it count?
Why? Because the calculator is only for like 0 to 90 degrees. Like anytime you do like the sine or cosine or something, it's only for that particular value.
I don't think that's a calculator's fault. I think it's.
Here we go. Your first example. You are solving triangle ABC. Now, when it says to solve a triangle, I covered this in first semester, but I will recover it today. Solving a triangle means finding all angles and all side lengths. Okay? Finding all angles and all side lengths here. Now, for me, because I have big handwriting, I am going to use this extra space here. You guys, it's up to you however you're going to do your notes, okay? But the easiest way, in my opinion, is to look at this as a triangle. That's just my opinion. So in that way, I can label everything. I know angle A is 45 degrees. I know angle C is 55 degrees. And I know that side C is 12. Side C is the side across from angle C. Does everybody see how that setup is? Any questions up to here? Now, if you look at this triangle and the way it's labeled, is this an angle side or a side angle situation?
Angle side.
Angle side, which means that do I need to check for a second triangle?
No, yes, no.
Which one, no or yes? No or yes?
No.
When do you check for a second triangle?
Side angle.
Side angle. So from here, I can find the rest of my information. Now, because I know two angles, I can find the third by doing what?
Sub.
But you try to equal to that.
Wait, hold on. Go ahead. There's 180.
I forgot the property we're doing.
You can add 45 and 55 together and subtract that from 180 to find the missing angle. There's 180 degrees in every triangle. And that will give us what? 80. So angle B is 80 degrees. So far, so good. So now all we have to do is find the two sides. What two sides are we looking for? Side B and A. So when you think about that formula for law of sines, we know angle C and side C, which means that we're going to use that part of the formula whenever we find A and B. Okay? So let's use this part of the formula to start with. We are going to be cross multiplying. So using that formula, it says B, which we don't know, over the sine of angle B, which is 80. We're going to set that equal to side C, which is, and we're going to divide it by the sine of 55. This is how you set this up. And now, if you want to skip steps all the way to get to the final answer, well, then that's on you. But don't be saying, well, why did I get this wrong if the answer is wrong because you didn't show any work. How do I solve something like this? Cross multiply. That's going to be B times the sine of 55 equals 12 times the sine of 80. Now, realize when you cross multiply, they equal each other. You don't divide them by each other. You equal them to each other. And that is a sine 80. If anyone asks, that's a sine 80. How do I solve for B?
Divide sine 55.
Divide by the sine of 55. And that's what you type into your calculator. 12 sine 80 divided by sine of 55.
I got like 14 plus 14.
Did we get this?
No.
14.4, oh, 42. My mistake. So it'll be 14.4. My mistake. I thought I just heard 2.
Is that equal to C, right?
So now we are trying to find side A. So we now use that part of the formula. A over sine A equals C over sine C. So that's going to be A over sine of 45 equals C, which is 12 over the sine of 55. And we do the same thing over again. Question?
If you were to take the exact value of length B, couldn't you just use Pythagorean?
That is a good question. Could we take side B and use Pythagorean theorem?
Yes.
No, why not?
Agree, something.
It's not a right angle. Now, if it was a right angle, yes.
We're working special.
A over sine A equals B over sine B.
I would not encourage using side B because that was something that you found. So if you got B wrong, you have no chance of getting A right.
Oh, yeah.
But using side C, you at least have an opportunity that if you missed B, you still have a chance of getting A right.
And then you go over and check your
Okay?
No chance.
So let's cross multiply and let's figure out side A.
I really don't want to say it, but this is easy. Just jinx this so hard. Just yeah, I don't like everything. And I think I'm only saying it's easy because we have calculators.
That means nothing. What'd you guys get for A?
10.35.
10.35, so 10.4?
Yep.
There you go. Questions? That is with the angle side situation. Let's look at one where it's a side angle situation, like the next, oops, not this one, like the next one. Okay? Let's draw a quick triangle out for this. Quick one. Let's label our sides. Remember, 10 is going to go across from angle A. 14 is going to go across from angle B. And 39 is going to be angle A. What should you find first? What's going to be the easiest piece of information to find first?
Third side. Nope, side.
Right, two triangles.
Say what? Why? Because you know A, you know all of A, and you know the side of B. So the one piece of information that would be the easiest to find is angle B. So let's set it up, and let's find angle B. I want you guys to use the formula, find angle B. And because we're looking for an angle, that means you're going to have to use the what? Inverse. Okay? Equations. Okay? So you should set it up. 10 over sine of 39 equals, you know side B, so it's 14 over the sine of angle B. You still do the same thing you did before. Cross multiply. That's 10 sine B equals 14 sine 39. Questions? Now from here, I have to solve for B. The first thing I'm going to do is what?
Cross multiply.
Divide by 10. I cannot divide by 10 sine because sine, just like cosine, just like tangent, is always attached to the angle. So first we have to get rid of the number that's in front of it. So you have sine B equals this whole thing, whatever decimal that is. So then to get B by itself, that's when you do the inverse. Because now I've gotten my angle and the trig function by itself. So at this point, then I take the inverse of that whole fraction, that whole decimal. Let's see. People type it in. What you get? 61.8? This is the first step of when you are dealing with a side angle situation, okay? You want to find one angle. Find the first angle, and it will be obvious, guys. Like you wouldn't be able to find C because you don't know side C. Okay? You find one angle. You find the first angle. Then the next thing you do is you take that answer and you subtract it from 180. That's the next thing you do. You take the angle that you just found and you subtract it from 180. Okay? So let's do that. 180 minus 61.8. 118 point what? 0.2. Okay. Now at this point, if there is two triangles, that is the angle for the second triangle's angle B. Okay? I will say that again.
That makes sense.
If there are two triangles here, then that means that angle B in the second triangle is going to be 118.2. So I'm just doing this just for visual purposes. Okay? Here's the second triangle, and to identify, I'm going to label these with 2's. Okay? Angle A is still the same. Side A is still the same. Side B is still the same. The difference comes here. In triangle 1, angle B is 61.8. But in triangle 2, it's 118.2. Questions up to? Yes.
Why are there two triangles?
Okay. This, with the ambiguous case, the reason why there will be two triangles is if that side is short enough to touch the opposite side in two different places. That's what I drew with the purple triangle and with the green triangle. Okay? Now, we always have to check in these situations to see if there are going to be two triangles. Sometimes there won't be, but we have to check in the side-side angle situation. Yes?
Can we do two triangles no matter what?
No.
No.
And then if how do you know when there's two triangles?
Okay, I'm getting to when you actually know if you have two triangles. Yes.
Wait, I forgot what I was saying. Like, oh yeah, if you said if we don't do the two triangles thing, we'll get the tensor wrong.
Yes. If there are two triangles and you only find one, then you won't get.
And then if we do the two triangle thing and there's not two triangles, that will get you wrong.
Well, no, you'll recognize. Like, trust me. Here we go. This is how you know if you have two triangles. This is how you know if you have two triangles. This is step 3. This is step 3. Change colors. Let me change the pink. I'm just writing them there for the folks who are like, I'm a step type of person, Ms. Anderson. What do I do first? What do I do second? What do I do third? Okay? What you want to do is now you want to find the last angle. Okay? That's the symbol for angle.
Triangle one.
I think I
And triangle 2, if it's possible. Okay?
Yeah.
Go ahead.
Okay, so is it like, you have two triangles, whatever your last angle, whatever added to one of the triangles says equal 180?
Correct. Alright? So, if I find angle C in triangle 2, okay, I always check that one first because I need to know if I'm dealing with two triangles or one triangle. When I add 118.2 and 39 together, to find angle C, what do I need to do from there?
Subtract that from 180.
Subtract that number from 180. So when I do that, do I get a positive number?
Yes.
So that means I'll have two triangles. If this number ended up being a negative, then I only have the one triangle, which was the pink triangle I started out with. But because when I add these two together and I get a positive number, I do indeed have two triangles, which means I'm going to have two sets of solutions. You can have 0 triangles. But the thing is that if you have 0 triangles, that means you would have found out from the very first step that you wouldn't have any triangles. Like you wouldn't even have an angle answer.
Prime says. Yeah,
Okay.
we don't have any triangles.
What's this number right here? 22.8. So that is angle C in this triangle. In the second one, yes.
This makes me cry. Math.
Okay? So again, because we have a third angle in the second triangle, we do have two triangles here, which means we'll have two sets of solutions. 2 angle B's, 2 angle C's, and 2 side C's. Okay? How do I find angle C? Now at this point, you find the last pieces of information. Okay? What's angle C in the first triangle? 79.2?
Yeah.
Okay. And again, you get that by adding 61.8 and 39 and then subtracting that from 180. And then you have to find side C for both triangles. Let's find it for triangle 1. So for triangle 1, that's side C over the sine of angle C. I'm going to set that equal to what in triangle 1? Using the law of sines, I would use A. Why A?
Because he was given that one.
You were given that. You found angle B.
So ideally, we don't screw up.
Sine 39. Cross multiply and solve.
Wait, did we check our answer right
No, we're finding the last piece of information.
now? Yeah, I have no space in the solution.
Well, that's why you have the extra space on the side.
Extra.
Can I get confirmation? I need confirmation. Check behind me because I don't have it. 15.6? Okay. So that's in triangle 1. That's this side. Now you have to find side C in triangle 2. I'm going to leave you guys to do that. Find side C in triangle 2. Okay, we're trying to find a side C in triangle 2. So you set it up the same way you set up for triangle 1. That is C2. Side 2. Or side C in triangle 2. Over the sine of 22.8. You set that equal to 10 over the sine of 39. Use what you're given. Cross multiply and divide. And what is C2? What you get?
6.57 or 6.157.
So 6.2. Okay? So just to recap, when do you check for two triangles? Side angle. And to determine if you have two triangles is you start by finding one of the angles. It'll be very obvious. Now, once you find that first angle, you take that angle and you subtract it from 180. That's what we did here. Then that's going to be the potential angle B in the second triangle.
Okay.
Then you determine if you have two triangles by adding, we added the 118.2 and the 39 and subtracting it from 180. Basically, we're finding the third angle. If it's positive, we have two triangles. If it's negative, we only have one. And because it was positive, that was angle C in the second triangle. And then we find the remaining pieces of information. Okay? Now, this came up before. I'm going to address it again. Yes, you can have 0 triangles. Okay? And you'll know if you have no triangles is if you try to find the first angle and you get an error message, and you double check your work and you get an error message again, that's when you'll have no triangles. If you're thinking to yourself, well, Ms. Anderson, how do you not have any triangles? That happens when that side is not even long enough to reach. Okay? That's when you have no triangles. Okay? It can happen there, and it can happen here. Okay? That's when you can have no triangles.
Can cosine doesn't like that.
So you can have either no triangles, one triangle, or two triangles. And that only applies in the side angle case. If it's angle side, you'll have one triangle always.
And also if the angles don't line up right, like for the second triangle.
Correct. Yes.
Is that further notes for today, or was
No, that's something I was going to use it for as a visual. Yes.
Where did you check if it was positive or negative?
When we're looking for that third angle.
Alright.
And if it's positive, 2 triangles. If it's negative, 1 triangle.
If you get an error message to
But that would have been back at first step.
earlier.
All right. What I want you guys to do. This is the extra one. This is the one that you're going to be doing in the space. If you don't have the space, just swing over to the next page, and then you'll just fold in the prep work on that page. But I want you guys to work this one out.
You think this is enough space?
Off the top of my head, I cannot say.
Schizophrenia.
And now it's all for
Let's see the difference between B2 and A2. Minus 180.
What? For B2, did you guys get 161?
I got
Yeah.
I got 140.
Boys.
Yeah, I kept it.
This was a side
I
angle situation.
All I can do is find the sides now. Right, let's go, boy.
Soccer.
So C2 should be like 7.9 or something?
C2 is from B2. Yeah.
It's a French. Did the sides change on the second
And then after that,
No.
you're missing
No.
2 more sides, right?
That don't change.
At that point, you're just missing C2 and C1.
Is that what you guys got?
Yeah.
Yes.
So what was angle B?
35.9.
What was the number after the 9?
A 3.
Okay, just making sure. So that is angle B in triangle 1. You do, because you have an angle, you have to check for a second triangle. So we know that this is 35.9. To check for a second triangle, we subtract this from 180. What do you get?
144.
44.1. So that means in my second triangle, if I do indeed have a second triangle, B is going to be 144.1. A is still be 28. Side A will still be 4.8. And side B will still be 6.
Yeah.
Because you subtract the angle from 180. Now, you know if you do indeed have a second triangle is if you take this angle in triangle 2, add these up, subtract it from 180. When you did that, what was angle C?
7.9.
Because it's positive, you have 2 triangles. Okay? So right here, I already have the angles done for triangle 2. What's angle C in triangle 1? 116.1. Perfect. So now I have to find side C in both triangles. If you didn't round.
I'm in. I think it's so.
Well, if you didn't round, then we'll be different just by a few like tenths.
Yeah.
We set it up to find C this way. I am going to skip a step. That's what I would plug in. You got it. That's what I'll plug in to find C1. And what is side C?
That one.
What you guys get here? 2.8.
8.
Wait, what was that?
I got.
For triangle 1, it couldn't be 2.
I got 9.18. It's 9.2.
There we go. 9.2.
Well, I got 9.8.
This is one thing. I kind of had a feeling that something was a little off because in triangle 1, I think I might keep saying triangle 2, so I'll do a pause. In triangle 1, angle C is my largest angle. which means it needs to be across from my longest side. So whatever I find for C1, it should be bigger than 4.8 and bigger than 6. So there it is. And lastly, I'll set it up the same way to find C2 in triangle 2.
It can't get more difficult than this one.
I'm going to skip a step.
Don't say that.
It's not, you seem to forget that.
I know what you said, but this
You got that.
And what do you get? What you guys get for side C in triangle 2? 1.4. Questions?